Okay, today we're going to talk about a normal distribution, which is a type of density curve. It's just a specific type of density curve that we use a different way to find the area underneath. Okay, so very basic here, we have a mean of 80. So the mean goes right in the middle, and a standard deviation of 10. Okay, we had talked about that. All of the data falls within 3 standard deviations above and below. So 1, 2, 3 standard deviations to the right, 1, 2, 3 standard deviations to the left. So if the standard deviation is 10, this next number to the right is 90. That's 1 standard deviation, and then 100, and then 110. And the other direction, 1 standard deviation away of 70, 2 standard deviations is 60, and 3 standard deviations is 50. Then we have the empirical rule. This is how we can use this rule to make just a rough guess about what proportion of the data falls between certain values. So what this says is that 68% of the data falls within 1 standard deviation. So 1 above and 1 below, 68% of the data falls in there. Okay, the darker blue goes on to include up to 2 standard deviations. So 2 to the right and 2 to the left. That total area in the middle is 95% of all data. And then if we continue out to 3 standard deviations above and 3 standard deviations below, that's almost all of the data, and we say that's 99.7% of the data. So here's that written out in words. 68% fall within 1 standard deviation, 95% fall within 2, and 99.7% fall within 3. This only works on a normal distribution or bell-shaped. That's the only time that you can use this. Okay. So, some other values we can calculate. If we know 1 above and below is 68%, then we know that if we're looking from 0 to 1, half of 68 is 34. So if we're looking for data here, that would be 34%. Same with the other side would be 34 for a total of 68% in the middle. Okay, if we were looking from 0 to 2, the mean to 2 standard deviations above, that would be 47.5%. That's half of 95%. And same with the other side is another 47.5 for a total of 95%. We can do the same thing continuing out from the mean to 3 standard deviations above would be half of 99.7, which is 49.85%. Same on the other side for a total of 99.7%. So we can use this to answer specific questions. So if we know the average adult male is 69 inches tall with a standard deviation of 2.5 inches, we can go ahead and write out 69 inches is the mean. 1 standard deviation above is 71.5. How did we get that? By adding 2.5. It's 2.5 standard deviations. Another 2.5 and another 2.5. So we can answer all kinds of questions based on that. Okay, so looking at that same data, what is the likelihood that a randomly selected adult male would have a height less than 69 inches? So here is 69 inches, and we want less than that, which is this whole side of the bell curve, which you should know would be 50%. But what I want you to pay attention here is the symbols that we use to represent this. So P is the probability that one male height, so lowercase h is less than 69, equals 0.5 or 50%. Okay, now we're going to go ahead and look at some examples. So open your packet to what's now the first page in the packet, and we'll walk through some examples. Okay, so here's your worksheet, and this is the same data of the height of men. So our mean is 69 inches. So right here in the middle, we're going to label this as 69 inches. Okay, and now we want to paste this out correctly. So what we're going to do is we're going to go out here to the very tail. And the very tail out there is 3 standard deviations away. Okay, and then we'll draw in our other values based on that. So that we have 1, 2, and 3 standard deviations away. Okay, so 1 standard deviation above would be 71.5, 2 would be 74, and 3 would be 76.5. And then we have the same thing going the other directions. We have 66.5, 64, and 61.5. So now we can answer all kinds of questions based on that. What is the likelihood that a randomly selected adult male would have a height of less than 66.5 inches? So what we're going to do is draw a line at 66.5 and shade to the left. That's what we need, is that area to the left. Okay, so what do we know using our 68, 95, 99.7% rule? Well, we know that within 1 standard deviation, sorry, my things are actually really off. It's harder to do on the computer than paper. So this area in the middle is 68%. So what is each tail? Okay, well, 100 minus 68 is 34. So these 2 tails together add up to be 32. Just kidding, 32. So each tail is 16. So this is 16, this is 16, and the middle is 68. So the probability that H is less than 66.5 is equal to 0.16, or 16%. Okay, so moving on to number 2. And what I like to do when I'm graphing this is to write these numbers up top here in pen, and then you can use pencil to draw and shade and calculate, and then you can erase them as you go from problem to problem. Okay, so number 2, what is the likelihood that a randomly selected adult male would have a height of greater than 74? So here we are looking for greater than 74. That's this tail right here. So we need to use our rules again. So that's 2 standard deviations away. If I go to this direction, then I know that 95% of the data falls in the middle there. So to get each tail, I'm going to do 100 minus 95, which is 5%. So the 2 tails together total 5%, so each one is 2.5%. Okay, or 0.025. So the probability that H is greater than 74 is 0.025, or 2.5%. Number 3, what is the probability that a randomly selected adult male would have a height between 64 and 76.5? 64 and 76.5. So, we're going to draw those pieces. 64 to 76.5. We want this whole middle, and we are 2 standard deviations to the left and 3 standard deviations to the right. I think that the easiest way is to always look at the tail probabilities. So we always want to look at the tails. So if you take in just a general sense, if 68% is in the middle, then each tail is 16. If 95% is 2 standard deviations away, then each tail is 2.5. And if you look at 3 standard deviations away, 99.7, then the tails total are 0.3, so each tail is 0.15%. 0.15%. So what I try to do is remember the tails as well as the 68, 95, 99.7. So the bigger tail is 16, 2.5, and 0.15. So this tail right here that I don't want is 2.5%. This tail out here that I don't want is 0.15%. So I want 100 minus 2.5 minus 0.15. Okay, so here you get 97.35 for the probability that the height is between or greater than 64 and less than 76.5 is 0.9735. Now there's lots of other ways to use this rule and these pictures, but I like to work in the tails, but you're welcome to do it other ways. Okay, then next you have this set of data below, which are IQ scores. Go ahead and pause now and work through those on your own, and unpause when you're ready and the answers will magically appear. Okay, the answers are here now, and hopefully you got all of these correct. If not, please work together and try to get through some of the more difficult ones like number 6. Thanks and have a great day.